So in this lecture, we're going to talk about network devices. We're going to talk about all the pieces and parts that make up our networks. So the first one we're going to talk about is kind of an older device. It's called a hub. And there were three types of hubs. There was passive, active, and smart hubs. Hubs are older technology, and you're not going to find them very often in your networks anymore. They've been upgraded now to switches, and we'll talk about those in a second. But essentially, a hub allows you to interconnect. Those hubs create more ports, just like we talked about with USB, where you can add more and more USB hubs and daisy chain them. With hubs, if you daisy chain them too much, though, you'll get more network errors. The way a hub works is it receives information on one port, and it broadcasts that out all the other ports. So, for instance, in this class, if Sarah wants to talk to Joe, if we were in a network, she'd have to come to me as a hub. And then I would go and say, hey, Joe, I have a message from Sarah. Here it is. And I would basically be the middleman passing those messages back and forth. With a hub, though, they were dumb. Okay, they didn't know who people were. So essentially what they would do is if Sarah said, I have a message for Joe, I would then stand up here in the middle of the class and go, hey, if you're not Joe, cover your ears. Joe, here's a message. And I would tell Joe what it was. So you could tell pretty quickly how this is a security issue, right? Because Nick can easily go, I'm not going to cover my ears. I'm going to listen to the message anyway, right? So that become a problem. So that's why we don't really use hubs anymore. We end up using switches instead because of a security issue as well as a speed issue. So with a hub, there's three different types. There was passive, which all they did was they would repeat the signal they got in. There's active, where they actually take that signal, they boost up the signal, and then send it out again. And this is important because networks with standard Ethernet cables have a 100-meter limit. After 100 meters, the signal won't travel. It's just too far. But if you use an active hub, you could then hit that active hub, and it would start that 100-meter count all over again. So you could extend these networks further that way. And then the smart hubs, they were active hubs, but they have some extra enhanced features. Again, you're not going to run into hubs very often. They're really an old technology, and they're not very secure. The other thing about hubs is they act very slow, because if I'm talking and passing that message from Sarah to Joe, everybody else has to wait while I'm talking, right? Because I'm broadcasting it out all the ports. With a switch, we actually added some intelligence, and we'll talk about that here in a second. So a bridge is a layer 1 device that's used to connect multiple network segments together. So if I have a LAN on one side and a LAN on another side, I want to connect them together, you could bridge them together using this device. It then creates different collision domains, and that way large numbers of devices can actually be connected to the same Ethernet network. And the way bridges work is they actually look at the source MAC address and the destination MAC address, and they build a table based on that. So why this is important is I have two sides of the room here, right? Sarah's on one side and Joe's on the other side. With a bridge, what we would do is we'd have a hub on each side and a bridge in between them. So when Sarah says, I want to talk to Joe, when she does it to her hub, the hub goes and sends it out to the bridge. When the bridge gets that message, it's only going to send it out the right side or to this side of the classroom where Joe's sitting and not bother the three people on the left side of the room, right? So that way, these guys can continue on their work while I bug these three people. Again, not as good as if I just went directly to Joe, because now I'm bugging Joe, Dave, and Charles. But at least I'm only bugging 3 people and not 6 people, right? So these bridges make these intelligent forwarding decisions. As you see at the bottom, bridges are obsolete today. The reason why we bring up hubs and bridges is because when we look at switches, they actually combine those two technologies, and they actually give us a lot more features by doing that. Which brings us to switches. And here's a picture of a switch in a network. It acts like the hub, but the difference is it's like it has a hub, but it has a bridge on every port. And so what that really means is here I'm sitting here as the switch, and Sarah says, I want to talk to Joe. Instead of me rebroadcasting that out to everybody, I go, I know where Joe's sitting. He's sitting on port number 3. So I only send out her message out port number 3. That means all the other people of the class can do what they need to do, and only Joe's being bothered with the message, right? Who needed the message because it was going to HIP. This frees up a lot of bandwidth on the network. And it makes sure that Nick can't listen in to Joe's conversation, right? Because it wasn't addressed to Nick, it was only addressed to Joe. And so now I basically, if you think of an old telephone operator, you guys saw those old movies where they take the plugs and they plug them in and they switch the people between, that's what a switch is doing electronically. It says, oh, Sarah and Joe want to talk. Let me put them in their own little talking network and they'll talk. And at the same time, Nick and Nick can talk, or Dave and Charles can talk. And so we can have 2 or 3 conversations going at once, whereas with the hubs, we all had to wait until Sarah and Joe were done talking before the next person could talk. So that's the benefit. And they do this based on what's called the MAC address. We'll talk more about those later. but that's essentially a unique hardware identifier for your network call. And that's how it knows who it's trying to talk to. It's not really saying I want to talk to Joe, it's saying I want to talk to Joe's MAC address. And these provide us more security and more features for efficiency and speedy network access. So routers. As you can see here in my network, I have a hub on the right with 2 clients. They're part of their own network. And I have a client with the file server and the client on the left side connected to a switch. If I want to connect these 2 together, I'm going to use a router that actually is going to split this network in 2. Okay? It is going to connect multiple networks together. In our example here, we're connecting to the outside network, the WAN, the remote network, and then bringing it into the router, which can then give it to this local area network. Routers tend to be very feature-rich, and they have a broader range of interface types than multi-layer switches do. And they can make forwarding decisions not based on MAC addresses, but they do it based on IP addresses. And we're going to talk a lot on IP addresses later. We have an entire lesson dedicated to IPv4 and IPv6. But each port on the router is its own collision domain and its own broadcast domain. And what that means, being a collision domain, is if I go out and talk, who's going to hear me, right? With a hub, everybody on the same hub is in one collision domain. So in this classroom, we're operating in a hub environment, right? When I speak, everybody hears me. If we were doing a switch, I would take, me and Joe, and we would sit in one corner, and I'd put Dave and Chuck in another corner. We'd be in 2 separate broadcast domains, right? With 2 different, collision domains. They can have their conversation, and we can have our conversation without having that bleed over. That's the idea of the collision domains. With a router, every port becomes its own collision domain, so it breaks up those collision domains so we don't have collisions where traffic has to be rebroadcasted, resent. Network adapters. So if you want to connect to the network, you have to have a network adapter. This can be wired or wireless, and they can be connected many different ways. It could be integrated into your motherboard. It could be a PCIe expansion card or PCI expansion card. They could be USB adapters, or they can be PCMCIA or card bus adapters for laptops. This allows us to connect our workstation to the network through the use of media. And we talk about media, we're talking about cables or wireless signals. It acts as the converter from the computer to get those logical ones and zeros to a physical electronic signal onto the network to transmit it. In this case, we have network cards, network adapters in all the clients and all the servers on this network, as noted by those red arrows. So what is media? Media is the cables or the wireless signals that we're using. It's used to connect 2 ports, such as the computer to the switch or the switch to the router. These can be made out of copper cable, or they can be made out of fiber optic cable, or they can even be made out of radio frequency waves if you're using wireless networking. These vary in cost, bandwidth, capacity, and distances, and we're going to talk an entire lecture on media and the different types of media that we have. So we'll get more into it later, but for now, when you think of media, think of the cable that connects your computer to the internet, right? Or to the network. So voice over IP service. I'm sure you all have used this by now. But essentially, about 10 years ago, this was a brand new concept. And what it does, it provides telephone access for your business or personal use. This can be either a software solution like Skype, or it can be a hardware solution like Vonage, or Magic Jack, as I showed here in the picture. If it's a hardware solution, it's going to use what's called an ATA, an analog telephone adapter. What that does is it's going to take your RJ11 phone cable and plug it to your phone, and then create the hardware solution for you to make that phone call. If you have a VoIP router, something like UMA or Vonage, that is the ATA as well. Different things that we deal with VoIP is things like quality of service, to making sure that it is a high quality connection. The FXO port for analog telephones, where you plug in an old school telephone and be able to make that internet call. It uses what's called real-time transport protocol or real-time transport control protocol and session initiation protocol. For the A+ exam, you don't need to know VoIP in depth, but to understand that we do make voice over internet is the way that we make phone calls, and that's how long distance has become pretty much a thing of the past. Everything now is pretty much considered a local call, right? Back in the day when I was a kid, you picked up the phone to call grandma across the country. It cost you 10 or 15 or 20 cents a minute. Nowadays, anyone in the US is considered a free call. Because we're using voice over IP, there's almost no cost to it. It's very, very inexpensive. Some other network devices you may run across. A wireless access point. A wireless access point, what it allows you to do is create those wireless signals, capture them, and connect you back into the network. So we'll talk more about those later on when we get to the wireless chapter. Network attached storage. If I take a hard drive with a network port on it, some of those are like cloud drives. You can actually plug them into your network and have that as a file server on your local network. That's called network attached storage. Modems, very old technology. We don't usually use analog modems anymore, but we still use cable modems and we still use fiber modems if you're using that for your internet service. But a modem stands for modulate, emodulate. In the most basic of modems, the old analog ones, it actually would take your ones and zeros from your computer and create an audible signal that would then be transmitted over your phone line to a service provider who would then provide you the data back. A firewall, we'll talk about that more when we get into security, but firewalls are going to protect your network from intrusions. They can be hardware-based or software-based. And then the last thing we're going to talk about here is internet appliances. So these are easy internet devices. They can be tablets, they can be your thermostat in your home, they can be web cameras throughout your home for your security system. They could be something like a streaming media player like a Roku or a Netflix box. These are all considered internet appliances. They're basically mini computers that do a single function or just a couple of functions, right? So if you think of like a streaming media box, like a Roku box, you can play some games on it, you can watch some TV on it. That's about it, right? That's the idea of these. So, which of the following devices transmits data to all the ports regardless of the final destination? Would be a firewall, a router, a switch, or a hub. A hub, right? We use that example of if Sarah wants to talk to Joe, I just say, hey, Joe, everybody else cover your ears, I'm talking to Joe. We just trust that you all aren't listening, right? That's how a hub works. With a switch, I would actually put them on a phone call together so only they could talk. So that would be a hub. You guys are correct.